Hi guys, in this episode of Shri series, we're going to be talking about index laws, but to be more specific, negative indices. All right, because one thing that we need to understand, or one aspect that we need to understand with index laws, is when we not only deal with positive numbers or positive indices, but we also deal with negative indices. All right. So before I proceed any further, let's do a quick review on the index laws that we did before. All right. So if you've been watching my previous videos, you should be able to look at the index laws that we visited, as well as some examples to help enhance your learning. All right. So if you remember the first law, which is the addition law, suppose you've got a to the power m times a to the power n. That's the same as a to the power m plus n. All right. A simple example, let's say 3 to the power 4 times 3 to the power 8. That's going to be 3 to the power 4 plus 8, which is 3 to the power 12. All right. So that's rule number 1. Okay. And there are further examples in my previous videos that you're more than welcome to look through. Right. The next rule was the division or subtraction rule, which is the opposite. Suppose you had a to the power m divided by a to the power n. You could say that's the same as a to the power m over a to the power n, which is the same as a to the power m minus n. All right. A simple example, let's say you had x to the power 5 divided by x to the power 2. That's the same as x to the power 5 minus 2, which is x to the power 3. All right. So that was the division rule. All right. Now let's look at the other rule, which is the bracket. So suppose you've got a power in a bracket and a power outside the bracket. What do we do when we in a situation such as that? Okay. So let's say, for instance, we have a to the power m, all in brackets, to the power n. What does that mean? All right. So if you recall, that's a to the power m times n, which is a to the power m n. All right. A simple example, let's say x to the power 3, the whole thing to the power 5. That's the same as x to the power 3 times 5, which is x to the power 15. All right. So that is the third index law. I tend to call it the bracket law or the bracket rule. All right. The next one is the power of 0. All right. And I did mention previously, this is obviously the easiest law or rule to understand. Suppose you've got a to the power 0. That's the same as 1. All right. And a simple example, suppose you've got, let's say, 100 to the power 0. That's going to be 1. Okay. Let's say, for instance, you've got 2p to the power 0. That's the same as 2p to the power 0 is 1, and 2 times 1 is equal to 2. All right. So if you want to look at further questions on powers of 0, please look at my previous videos to gain a much more understanding theory of how it works, as well as some questions that we can go through. All right. Now let's look at negative indices. All right. And I just wanted to use this video to explain, because this can be sometimes complicated, especially when you've got negative numbers and students sometimes make a mistake. They can understand the addition rule, they can understand the subtraction rule, they can understand the brackets or anything to the power 0. So in other words, the 4 rules that I showed before. All right. But when it comes to negative indices, sometimes students find that a bit tricky. All right. So it's important that we look at the fundamental rules and then work through small questions and then go into more complex questions. All right. Now, let's say, for instance, okay, you've got a to the power 0 divided by a to the power n. Okay. Now you can see that is the division rule, or in other words, you subtract your powers. Now we know very well a to the power 0 is 1. So that's 1 divided by a to the power n. And technically, that's the same as 1 over a to the power n. All right, because that's how we are dividing. Okay, so technically the negative law states that when you've got 1 as your numerator and then it's over a to the power n as your denominator, you can express this as a negative index, and that becomes a to the power negative n. All right, that's a to the power negative n. So you can see, in order for you to understand this, you need to know the second law, which is the subtraction law that applies to division. So a to the power 0, all right, if you look carefully, that is 1. And that's why a to the power 0 is 1 divided by a to the power n. What I've simply done is I've just put 1 as my numerator and a to the power n as my denominator, and that becomes a to the power negative n. It's as good as saying 1 divided by 4, that becomes 1 over 4. That's exactly what I've done here. 1 divided by a to the power n is 1 over a to the power n. Another way to interpret this law is to simply use the second rule, which is the division or subtraction rule. We know very well a to the power 0 divided by a to the power n is the same as a to the power 0 minus n. And if you look carefully, 0 minus n is actually negative n. So that now becomes a to the power negative n. And can you see that is the same as that? So that tells you a to the power negative n, you can rewrite that as a to the power, 1 to the power a over n. All right. Sometimes if you're not able to see this bit, I'll write it here. So that's the same as 1 over a to the power n. All right. So before I just simply tell you the rule, I thought it was important that we explain how we came up with that rule, because mathematics is not just about putting theories out there, but showing the reason before an accepted theory. All right. Why is it 1 over a to the power n is actually the same as a to the power negative n? And if you look back, if you use this bit here, a to the power 0 divided by a to the power n, you can express it as 1 divided by a to the power n, because a to the power 0 is 1 over a to the power n. Or you can simply subtract the powers, a to the power 0 minus n, which is a to the power n, and you can see that that's equal to that. So in a nutshell, the rule for negative indices is what you can do, and I'll just rub here, is simple rule: 1 over a to the power n is the same as a to the power negative n. That is the negative index rule. All right. Now, when I write this down, it looks very simple, because all you can say is, oh yeah, 1 over a to the power n is a to the power negative n. But the complexity changes when we solve different types of questions that involve 3 or 4 index laws in one. All right. Now, that ultimately is the challenge. Those are more complex questions. But before we go there, I think it's important that we build our confidence and solve smaller questions, and then we move on to intermediate and then complex questions. All right. So now that we've established 1 over a to the power n is equal to a to the power negative n, let's do some questions. All right. So let's start with the simple numerical one. So in that way, we build our confidence, and then we move on to questions where you've got numbers and letters. All right. Now, we know very well 2 to the power 3 is 2 times 2 times 2, which is 8. All right. We know 1 over 2 to the power 3 is 1 over 2 times 1 over 2 times 1 over 2, which is 1 over 8. All right. Now, this is pretty straightforward. I don't think I need to explain any further because it's self-explanatory. You're getting the power, multiplying it 3 times. You're getting the same number and multiplying it 3 times because it's a cube. All right. Now, let's say, for instance, let's look at the second question. we know very well 1 over 2 to the power 3 is equal to 1 over 2 times 1 over 2 times 1 over 2 times 1 over 2. This 1 over 8, you can rewrite this as 8 to the power negative 1. Alright, because the rule states that 1 over 8, you can write that as 8 to the power negative 1. Alright, so let me go back and explain to you how we can get back to the question here. Do we all agree that 1 over 2 to the power 3, that's the same as 2 to the power negative 3? Alright, because that's the index law. Remember, the index law states 1 over a to the power n is the same as a to the power negative n. Alright, so that's not rocket science, we've just substituted. Okay, and that becomes the same as 1 over 2 times 1 over 2 times 1 over 2, which is 1 over 8. That also is the same as a to the power negative 1. Alright, so you can see that's the basic representation. You can write it as a fraction or you can write it as a negative index. So 1 over 8 is written as a fraction. And 8 to the power negative 1, you write it as, or you express it as a negative index. Alright, so it's very important that you understand the correlation between writing a fraction and writing a negative index, because a lot of times these questions can throw students off. Alright, with that in mind, let's look at simple examples. So suppose I have a question. Say for instance, x to the power negative 4. How would I write that? Okay, now let's say for instance we have, say for example, x to the power negative 4. That is a negative index, and let's say I want to write that negative index into a positive index. That now becomes 1 over x to the power 4. Alright, now if I've got 1 over x to the power 4 and I want to convert it into a negative index, that now becomes x to the power negative 4. All right, so that's a pretty straightforward question here. Let's look at another one. All right, suppose we have, let's say for example, 7 x to the power negative 4 y to the power 2, and I want to write this negative index into a positive index. All right, how would I write that down? So what that would now become, that x to the power negative 4 becomes 7 over x to the power 4. So you put 7 y squared over x to the power 4, because you know very well that negative 4 means it's 1 over x to the power 4. Again, if you found that a bit confusing, just remember x to the power negative 4 is the same as 1 over x to the power 4. It's sort of like that. We're just adding on. We're just adding more layers to increase the complexity. But it's exactly following the same rule of negative index or negative indices. All right. Now let's look at another question. Okay, let's look at another question. Suppose we've got 10 over x to the power negative 5. How would I convert that negative index into a positive index? All right, how does that work? Now, you know x to the power negative 5, that actually becomes, if you look very carefully, that's the same as, so x to the power negative 5, if you look at it, is the same as 1 over 5. Or should I say 1 over x to the power 5. All right, now we want to put that up there. So it's the same as, suppose I got 1 over 2, that's the same as 2. So 1 over x to the power 5 becomes x to the power 5, and that explains why the answer now becomes 10 x to the power 5. So that's how we convert negative indices to positive indices. it's always important to understand the inverse law. So the other word for negative index or indices is using what we refer to as an inverse law. The word inverse means 1 over. All right, so if I say what is the inverse of 2, that's 1 over 2. What's the inverse of x? That's 1 over x. What's the inverse of x squared? 1 over x squared. And you know 1 over x squared is the same as x to the power negative 2. All right, or 1 over x is the same as x to the power negative 1. So that's how we work through negative indices. All right, let's look at another question. All right, like I said, what we're doing is we're adding further layers. All right, so we can apply probably 1 or 2 laws, including the negative index law, to a particular question. All right, so you just write that properly. So we're still on negative indices. All right, so suppose we've got a question. All right, let's say 5, all right, x squared over y to the power 4, the whole thing to the power 3. All right, now let's say in place of x, let's put in place of y, let's put x. Sorry, so we put x to the power 4. All right, so 5x squared over x to the power 4. How are we going to solve this? All right, now we know very well, if you see what sort of rules can we apply, I can say we can apply this rule, a to the power m, the whole thing n, which is a to the power mn. All right, because you've got an x squared and a cube there. All right, and I think we can also apply a division rule, which is say a to the power m over a to the power n is the same as a to the power m minus n. All right, so you can see we've got 2 different rules to apply, and I can also foresee we can have a negative index as well here. All right, so let's progressively work through this question. Okay, so the first thing we need to do is work out what's in my brackets. That's the same as 5 to the power 3 and x squared to the power 3. Now we know 5 to the power 3 is the same as 5 times 5 times 5, and x squared to the power 3 is x2 to the power 3. All right, so if I was to now write the complete answer, 5 to the power 3 is 5 times 5 times 5, which is 125, and x squared to the power 3 is the same as x2 times 3, so it's x to the power 6 divided by x to the power 4. Now, the beauty about this question is all we simply need to do is say 125 x to the power 6 minus 4, which is 125 x squared. All right, so there is no negative index here. All right, now what is important here is I'm not going to get the full marks. Why will I not get a full mark in this question? Because I've done the top bit, but I've forgotten to do the second bit. All right, because I've put x to the power 4, and this is where I want to explain to students. A lot of students think that that cube or that power is only relevant to the numerator and not the denominator. It also includes the denominator because you've got the whole thing in brackets. However, if we only got a bracket in your numerator, then it will become x to the power 4. So clearly, I've got my numerator correct, but I failed to work out my denominator. So I will get 1 or 2 marks, but I'm not going to get full marks. So how do you think I'm going to work through this question? All right. If we had a question like that, we can simplify it to get 125x squared, but that is not the case. All right. So what I'll do now is we'll go a little bit behind. I just wanted to show you what errors students can make. And what I'll do here is we know 5 to the power 3 is 125. So x is going to be 2 times 3 and x to the power 4 times 3, because we've got to do the same thing with your denominator because we're looking at the whole bracket. So what does that now become? The answer simplifies to 125x to the power 6 over x to the power 12. Alright, so 125 x to the power 6 over x to the power 12. Now, there are two ways I can solve this. If the question asks me to leave it as a positive index, you can leave it like that. If the question says, no, I want you to leave it as a negative index, that now becomes 125 x to the power 6 minus 12. So that's going to be 125 x to the power negative 6. Alright, so that's 125 x to the power negative 6. Okay, now I want you to look very carefully. Really what we've done is subtracted that from that, and that eventually becomes 125 over x to the power 6. So what I've simply done is I've converted something that had a negative index, and because of this rule, 1 over a to the power n is the same as a to the power negative n. So x to the power negative 6 becomes x to the power 6. So it's very, very important to understand that sometimes we could leave the answer as a positive like this, but we've got to simplify it. Because x to the power 6 divided by x to the power 12 is x to the power 6 minus 12, which is negative 6. If the question said, leave my answer as a negative index, you choose this one here. But if the question says, no, I want you to leave the answer as a positive, then you leave it as this. Alright? Most of the time they ask you to leave the answer as a positive, but you got to remember you should know the correlation between converting a negative index to a positive index. Alright? In the next set of videos, we're going to be talking about complex index laws where we might have to apply all 5 in one. And that's where we need to go through a step-by-step methodical and logical process towards getting those marks. All right. Thanks for listening, guys. Bye now.